Hey, this is problem 5 on your gas law packet. So in this one, we want to calculate the final pressure, which is going to be our P2, inside a scuba tank after it cools from 1.00 times 10 to the third, which is 1,000 degrees Celsius. So that's our T1. And we're cooling it down to 25 degrees Celsius, which is our T2. And the initial pressure, the starting pressure, was 130 atmospheres. So that is our P1. So in this problem, we're using combined gas law. And since there's no mention at all of volume, we're going to ignore volume. So our formula will end up being P1 over T1 equals P2 over T2. Now, I like to go ahead and rearrange my formula. So I'm trying to get this by itself, so I'm going to cross multiply. So P2T1 equals P1 times T2. And I want to get P2 by itself, so I've got to divide through by T1. So my formula will be P2 equals P1 T2 over T1. Now I can just drop those numbers in there. But when we're using gas laws, I have to change my temperatures to kelvins. So 1 times 10 to the third is 1,000. So my T1 then will be 1,000. And we're going to add 273 to that. So then I get 1273 kelvins. T2 is 25 plus 273. And that was degrees Celsius on both of those numbers. And so when I get that answer, it's 298 Kelvin. So now I have my T1 and my T2 in their correct units. So P2 then is going to equal 130 atmospheres times T2, which is 298 kelvins, divided by that many kelvins. Kelvins is on top and bottom, so the kelvins cancel out, and you end up getting your final pressure, P2, to be 30.43 atmospheres. So that's how you work out problem number 5.